Welcome back, guys. Uh, Today I had to come back a little late because it was completely rainy in the morning, so there was no light. And now it's a bit sunny, so yeah, let's start the stream. So I thought, and here I am. And where did we leave off yesterday? Mm, Yesterday we were trying to actually get through the error why we were not able to actually, we were able to make the request, but the actual write operation was not working because there was nothing written to the block, actual block. And we were trying to do stuff there to see how we can fix it, but nothing seemed to be working there. Yeah, let's continue today. Let's see what's gonna happen. And yeah, then that high level overview of what I'm doing here is that I'm trying to write a file system for my own kernel. And if I need a file system, I also need a block layer. And currently, I'm trying to implement the block layer. And within the block layer, we want which IO because my setup is a Camo setup, and I'm using which IO specification 1.0, and it has a weird layout where we have to chain descriptors, and descriptors has to have certain structures, and also has to have certain permissions, looks like. And all of that, once we make the request, we should also handle the interrupts to make sure the request is processed, and so on. So today, yeah, let's continue. Yesterday, let's see. Mm, yeah, yesterday we wrote this example. We have the actual example that we want to actually make it work before actually trying to implement the full working version. Is that we want to simply write to sector 100 with some random string, and this is how it is. It's the data, and we are writing this into it, and we have to make block requests which is of a specific struct size, which is this. It's which block requests, and yeah, we filled up the request with type which is out, which is write, and we want to write to sector 100, and reserved is just 0. I haven't looked into it, but I guess it's just 0, and it's not gonna fuck with us so far. And after that, we also have to chain descriptors. So the idea here is that descriptors are just a layout. Let me just show you the layout again, just to remind you of what we are dealing with. Yeah, so which Q descriptors are like structures, and it has address, length, flag, and next. Address, and we have to pass in 3 descriptors because the first descriptor will have the request header, and we have to allocate a request header struct and take its address and put it here, and the address should be read only, and also it should be a physical address. And here, I don't know, my pages are not read only. I guess it's both read and write, but let's come back to it later. But the next descriptor should be the actual data that we want to read or write. If it's a write operation, then we just pass in the data into it, and it should be written there. And even here we just pass the physical address of the buffer, and the length, and the flags, and the next. And then we have the third descriptor, which is the status descriptor, which in case it's just uint 8, I guess. And we pass the physical address and the length. That is it. It should be good. Nothing much. And this is what we have done here. We have created three descriptors, and we have just incremented this because we actually have the descriptor q, and the descriptor q has a certain size. So if we want to actually write into that q, we just write into the index 1. The index 1 would be the size of descriptor into 0, and index 2 will be size of descriptor plus index 1, and descriptor 3 would be size of the descriptor into index 3. And yeah, nothing much. We try to allocate all of those stuff. The first one, we just pass the requests, and we have this helper that can convert the virtual address into physical address. And we also set the flags. The second one is the data, and we just convert it into kernel to user space. No, user space to kernel space address, and then and this naming is just so fucking wrong, but still that's what I named it, so I have kept it. And the third one is the status bit. We also set it, and the third one does not need a next bit because here we just don't set the next flag. So if there's no next flag, this field won't be accessed, so it's fine. After that, we also have to do one more thing. That is, once we have set up the descriptors, we have to take the index of the first descriptor and we write it into avail register. So there are three registers, the descriptor register, and the available ring register, and the used register. Descriptor register is where we write these descriptors, and avail ring is where we actually tell which index the current request is. So in our case would be just the 0th index. So we write to the 0th ring the index, and then we increment the index, and then we finally notify the virtual notify register saying that 0th index is the one that we wrote. Nothing much. And after that, we just have to wait for the request to be over, which we tried and it did not work. Because if we try, we run it, everything seems to be fine, and we get this random message too. And when we actually try to, yesterday I wrote a small Python script to actually read the sector directly, and when we read it, we don't see that there. We just don't see it. So yeah, now it's time to debug it. And yesterday we also tried to do one more thing, which is when we actually run it, not this, when we run it, and we can actually connect to it through NC, because we also mapped the monitor to this telnet port, and we can connect to that telnet port using NC, and we can type this command. Yesterday we figured out these commands. This is the one. It should give us the current, this is the status of the virch queue, and which device, this is our device, and which index we want the index 1, index 0, which is 1. And if we see we have proper avail used and stuff, so we definitely have written the proper values. Maybe then now maybe the question would be uh, what where exactly things are going wrong and which layer is it, or because there's multiple things that could go wrong. That's why yesterday by end of the video I was trying to debug it, and it was just hopeless debugging, and I was not getting anywhere and I stopped. So today we have fresh eyes, hopefully. Let's see. I have no fucking clue of what I'm supposed to do. That's whole point of the discovery phase. We just figure it out to see one step at a time, to see maybe we miss something. We can just try it out and do something. Okay, so now that all that rambling is done, let's do something actually. Okay, so what can we check? One thing I wanted to check is that because my memory maps is descriptors are just they don't have a specific permission, and do we need any specific permissions? This is what I wanted to confirm because I have no idea. So if I have multiple descriptors chained, is it mandatory to have specific permissions for them, or is it okay? Let's just check that, because if the way I phrased it, it don't work. Okay, whatever, let's just copy it and paste it here and say which IO specification on. And let's see. You chain multiple descriptors. There's a mandatory ordering rule for the permanent. Do I must place any device writable descriptor elements after any device readable descriptor elements? So I am the driver, and it is the device, and everything that the device has to write needs to be placed after the readable ones. Okay, but in my case I'm just writing, so the device is not gonna read anything. No, device is not gonna write anything, so almost every part of it is just read only. Okay, additionally, the specification notes that while devices may be reasonably limit on the number of description must be. I have no clue what that means. Now what I'm going to do is that I'm going to look into that actual memory location to see what we have written. Does it even make sense to debug this, something like that? So one more thing is that this Kernel log is just keep on filling up, and it's taking a lot of storage. It's slowing my fucking lap. Okay, whatever. Now that we have one thing to check, how do I confirm it? Should I check it in GDB, or should I just print it, Or maybe I check it through this NC. No clue. Let's just write down what we want to do, because sometimes it's hard for me to think about it unless I write. So what the fuck do we need? Here? We have written 3 descriptors. They are all chained together. Okay. And we have the registers updated correctly. Now let's do we have the descriptors in the memory aligned properly? I mean, this is one of the questions that we can answer. Let's just answer that. I think we just have to run it. We run it and we go here and we go here. Take this. Need it, but still. And we just examine it. 3gx. So if we print 3 things, how is it supposed to be looking? If we go to our virtual block and if we take the descriptor, okay, maybe it's because it has 32. Maybe we need to pack it properly. Maybe because it all has, this one looks fine, but this has different fields, so probably there is some padding that is fucking with us. How to make structs without padding in C. I think it's unpacked. Yeah, it's attribute packed. Let's just add this to all of our structures. I don't know if it will change anything. Let's try. Okay. Okay, let's try x3gx. 0x c 1 2 3 6 1 2 3. Do we see any difference? Not really, nothing much changed. It's almost the same thing. Maybe this value changed, maybe it's because it has a different thing. 0x 50x gx 0x c 1 2 3 1 2 3. Okay, now we have, let's just interpret this. Interpret, check if this memory is lined with structs descriptor of which q this is the descriptor. Let's see, because we need 3 descriptors. Let's see if it's aligned properly. So the first one addresses this and length is A11. That's too big. And flag is fine. Next is 1. And then we have the next one which is addresses this. And length is 200. And flag is 3. Wait. Flag is 3. Okay, if the first one is next and the second one is right and next, third one is just right. Okay. And we have the proper size here. But is it that big? A11 looks like a huge number. Hex to decimal. Is it 2575 bytes? What the fuck? What's in this? Oh, okay. I have it like this. Okay. Let's just put 0. Come on, 0 here. I don't know what we are supposed to put here because we actually passed the data in a separate chain. So I don't even know why we have to put this data field here, but it's part of the specification, so I have placed it here. Okay, let's try. That looks less now. It's just 1 probably, much less than what we had previously. And then okay, now let's check the request itself. I fucking hate this. It'd be so nice if we can have up arrow. Hmm. Man, I fucking hate this. We just have to hold it every time. Tab, defaults, temple tests. Let's put it here, and I want just, let's say 5. Can I write it? Okay. And let's copy it. I think I won't be able to copy it. Fuck it. Temp test. Oh, I have to go through this step. It's even worse than typing there. Okay. Now I need. Fuck. Let's see what's in this location. This location just has 4 and 64. It's supposed to have what? And what did I put in the first descriptor? Descriptor 1 is this, and it's is this. Okay. Descriptor 1, descriptor 2, descriptor 3, and descriptor 1 is supposed to have address of the requests, and the request is 400 and 0. I guess probably that's correct. 100 in hex is 64, I believe. I don't know. Okay. Now let's check C00, and we have the values, and then we have the what's it? The third one is, I guess, the status byte. So if we put it here, E123, and status bit is nothing. Right? It should have something. We have an address here and size and right. No, because it's the address of this, and the status is set to 0. I mean, status currently does not have anything. Okay, so that's fine. But the length should be at least 8 bytes, right? Wait, let's check. Yeah, it is CE00. And it does not seem to have it. It's the address. I have the address. What the fuck is that? I think here we would have that value, and this is supposed to be the actual uint8 value, and it's 0, so it is correct because this is the address and it is pointing to a uint8 and it should be fine. Okay, let's just confirm one more thing, which is just let's take this and put it here. Oh fuck, let's put 10 gx xc 1 to 3 6 1 to 3, and it's correct because we have 2, which is the flag, and 1, which is the size, and we have the address. We have the address, size, and flag. Let's just confirm it here. Oh, fuck you. What the fuck happened? Okay, I have to make it like this so that it will be visible. We have the first index, the second, and the third. Okay, let's take this, the whole thing. Let's see. Let's see if we have written the proper values. We have this first index, which is address, and we have the length, and we have the flag, and we have next. Actually, second should not have write permissions. Maybe that's the issue. I am trying to write to sector 100. So is this valid request? But for write requests, why do we even need the write flag? Device reads the data from guests. Device writes the completion status into guest memory. So the data buffer does not have to have this. The status buffer must have writes. Okay, so we already found one issue that we are doing wrong. We don't need right here because we are only supposed to read from this, and but this one needs right because the status needs to be updated, so we need right. And read only ones should be placed in the front and the right needs to be placed in the end. Okay, hopefully. Let's see. Let's see if anything changed at all. Oh, holy fucking shit. Let's put, what the fuck happens? /x 10 gx gx 0x c 1 2 3 6 1 2 3. Now we have the same flag here. Do we have 2 here? Why is it? It's okay. Yeah, because this is the actual next index. So that is also correct. Python 3 tests. It's not fucking written. Let's try one more thing. Let's try to write to sector 5. Let's just write to sector 5. And let's just update sector 5. Let's kill it and run it. Do we actually have to handle the errors? Only then will we. Nope, it's not that. Cat ext4 grep strings. It's not there. Okay, fuck it. How to get the all logs of the specific requests in which I I need to know what the fuck is happening. I have no fucking clue. Hopefully this is correct and it's not fucking hallucinating. Put it here, and I think that should be good. Do we need anything else? Should be good as long as that command exists. Bash builds. That was fast. Oh, maybe it's only because of that extra logging. It took 50 years for us. There's no camo 0, only there's camo 0 log. Let's interesting. And there's nothing here. Let's try with this. Let's check if the parameter exists first of all. What? We have two different definitions of the same fucking thing. We have virch.io used, then we are allocating it with virch.io. What the fuck am I even doing? And avail object is the same thing. I have here this, and for descriptor object it's the same thing. I have virch.io mapped. And we have blk out, which is also wrong. Okay, let's first of all fix this. It's in virch.io hutch 89. And what is the actual flag? Go blk t out. It should be 1, and I was flushing. What the fuck? Why do I even expect things to work if I don't even type things correctly? Okay, there was one error, and the second one is that I am in K-main in 2.11.2.17. Maybe I should also think about warnings. I thought if it's not an error, who cares? Here I have which-q descriptor, but I'm allocating which-q. I think this is just memory, so I don't know if that would cause a lot of issue, because as long as there is enough memory to play around. which-q avail and which-q used. I don't know. I don't know if it will make any difference, but it's better to not have fucked up things compiling. Do we have any worse? We have one more, which is I'm putting which-q star with expression type struct virch.io disk. What the fuck is that? And it's line number 217. Oh, fuck. And why did it even compile? That's just so fucking bad. Nothing. Still nothing. Still nothing. Let's see if we update the status bit. Do we get anything in the status bit? Because only if the status bit is updated by the device, then I can confirm that the status is updated. Also, one thing changed is that usually we used to get this message after 5, now we are getting after 6. I don't know, maybe. Maybe we don't overcomplicate it. Let's just put 0th index and remove this. We increment, we put the index equals 1. And reduce 1 to 0s here. Is it taking so fucking long for it to go through 100 iterations? I think it's over status bit and the second status bit. Then you can add one more 0 here, so you have enough time. Okay, the first status bit is here, so it did work. 1 and 2 and slash in here and slash in here. We are stuck in the second while loop, which is supposed to be just normal. That was so fucking quick. Even we got the second status bit. Okay, let's put another 0. That also didn't take much time. I think we'll have to handle the IRQ and see what does it say. Does it say anything at all? And one more thing I wanted to test is that maybe you could change the index and try it for a different index. That's for another day. We write 512 bit blocks. We have next, and right. Is the right correct? It is BL key out and sectify. Do we need reserved? Wait. If we go back to our setup, and in VLK requests we have the type, we have reserved, we have sector, and we have data. But this won't work. This will just throw error. And status. Okay. And descriptor is just address, length, and flags, and next. Maybe there's just 0 here. Which queue has 512 descriptors and avail and pat and used, right? Structs which queue okay, so we have queue size and avail maybe that's the issue. I'm actually supposed to write into the which queue, and where did I actually write the queue? I mean this structure. This is legacy. Oh my fucking god. See, this is the issue. I was fucking with the legacy version. Okay, now let's check the descriptor. Descriptor should be 64 bits and 32 bits. Little Indian. I think my dump is Little Indian. Is my HQ descriptor Little Indian format. Maybe that's the issue. Maybe I'm here. Is it Little Indian? I have no idea. If Little Indian means, I guess, from left to right. No me. Okay, looks like we have it correct. Where is it? Where the fuck did I leave? Okay, here it is. Next is 1, right is 2, we don't use indirect. And which queue descriptor but it did not say packed here. Okay, whatever. It should be address, length is U32, and flags, and next. So it's correct. And which queue avail is flags, index, and ring. But we don't have used event. Okay, let's remove this. And then used element is maybe it's different. ID and length. Used is flags, index, and struct ring, which I don't have. I don't even have the proper things and I'm expecting it to work. Okay, I have to define this too. Okay, I have it already here. Okay, and then we have the which queue. Which queue is unsigned int num. And then we have which queue descriptor, which is a pointer, and which queue avail, which is also a pointer, and which queue used. I have just confused the old specification with the new specification. Hopefully this is the new specification. Okay, yeah, it's Birch 101. Okay, it should be used. Does standard int have those things? I don't think it has. If I try LE64, I don't see it. Okay, now I have to figure out this which queue. Which queue is supposed to be var. Struct which queue, and we have a queue here. And what am I doing there? I have allocated a queue and I pass that queue to this init driver. And what does it do? Wait. I'm passing it to which queue object, which is I guess my own structure. And I'm passing this queue into it. If we go into that, do we use the queue at all? Okay, here we have init queue. There's no indication that we have used this queue anywhere. No, we did not use that at all. And what is the point of this HQ actually? Okay, we maybe if we just allocate it, we can just access the descriptors and avail and use internally. Probably that's the reason. So okay, instead of me having a separate structure, because I have this virtio object class, which is just virtio, and inside virtio I have all these values. Instead I could just put them here inside virq, and I can access them directly like this. I just put virq, avail, and ring, and a number, or whatever it is, whatever I want to do. But currently I'm just using virtio, which is my separate class, separate structure, and I can access anything from within that. Okay, that should not hurt us. Okay, let's try. Nothing changed, so let's run it. And it was so fucking quick. Previously, with all those logs, it would take eons to reach this line. But almost everything else works. Only thing that does not work is that after we write to that, we don't see the actual block being written. And do we have tail camel? Build it, run it. Yeah, take camel. Okay, now we have something. Okay, okay. Let's take that. X clip, cell clip. Can't open display. Oh, okay. I don't have this X clip here. Fuck me. Oh, it's only for my Ubuntu. This is my fucking Mac. I sometimes forget that. I have to manually fucking fuck me. I can do this. do this and space to select right. Shit, it's a shit show. It would be so fucking nice if we could just copy it with clip and I don't have to do any sort of extra stuff. How do this log look like? Ooh, that's a big log. Device is resets. Queue is configured. A descriptor table. Use string. Driver notifies the device that queue notify. But so there's no log for what happened after this, like the write request. Was it processed? Okay, I'll put trace block star. Okay. But if I put VLK, there won't be anything because last time I tried it. It did not work. See, there's nothing. Let's just put this. Kill it. And run it again. And check what happened here. We have the same fucking do we have anything extra? I don't think so. Because we have MIMO reads and some MIMO writes. And we just simply write those three values and we wrote the final thing and we don't still see anything else. Oh, those logs are not shown. Yes, does this command exist? Who knows? Let's try. It's so fucking quick. I still don't see it. I still don't see it. Nope, it's not here. Let's try the other way. We kill it, we kill it, we kill it, we run it, and we connect to it. Holy fucking moly. And she's not here. And we try this. Let's see. Can we see the live logs here directly? Monitor. Okay, so the actual logs will be in the... Okay, it's fine, it's fine. Control B. And I go to host, Kernel, and I put tail, camel. I know I have two. That's shit. Probably the highest bidder. Okay, run it. And nothing new. It's still the same fucking thing. What else can we check? Let's trace everything. Let's trace everything, and then we get the grep forward child. We trace everything, we kill it, and we try camo or camo, we kill it, run it, kill it, cat, camo, or it's in 0. Okay, nothing much. 1. And there will be a huge fucking log, so let's put grab AI. Should we only want Virchaio, anything with Virchaio, and there's nothing with Virchaio. BLK. That's even worse. Let's try C. 1 2 3. Nothing special here either. Okay, we can fucking kill this. We're running out of options. Maybe we can try the read then. Instead of write, let's try the read then and see what happens. But if we read, where exactly should we get the value? Maybe it's in the, it will be written into the data buffer. We need better logging, because somewhere something is going wrong silently, so we have no fucking clue of, either we have to write everything perfectly or find errors and fix it. And we seem to be writing everything correct. We have Q max size and we register this. Maybe it's not getting written into the actual location and it's just getting cached. But if it's not, if it's that's the case, then we should not see it in the which.io logs. In which.io logs, we are able to see the actual addresses. We have the wedge-q descriptor. We have the wedge-q avail. And we have the wedge-q used. We added the which.io page for the driver. And then what are we doing here? We have which.io objects, which.io base, and device rich. What is device rich? Okay, it's the register for that device, so it's the base address. And the base address, this is just our own version that is just keeping track of the addresses for virtual address for the descriptors avail and use, and the physical addresses too. And then we have the actual wedge-q, which we are not using anywhere, but it's still there. And we initialize the driver. Let's go into driver once more. We just update, reset, we acknowledge it, we acknowledge the status, and we set it to driver. We select the upper half and we set the 32-bit, 33rd bit, which is just basic read and write operations. And we say feature OK. Maybe this is the issue. Let's not set anything. And if we set feature OK, well, let's see what happens. If we don't choose any features, If we don't choose any features, looks like nothing is happening. Yeah, still don't see anything here. And this message moved to 5th. Maybe that's some race condition. But still, we're waiting for status bit for a long time. Okay, let's switch this. First of all, status bit is never getting updated. Status bit is not getting updated at all. So what else could be going wrong? Because so far we are able to write everything and notify the device, and we don't get anything back. Guess we wrote that. What's this? Why do we need this step? Is it provided in specs 1.1? Or are you fucking hallucinating? I mean, queue ready, I have already set that to queue ready. Where is my queue ready? Maybe I did not set queue ready. No, I set queue ready for sure. I'm pretty sure about that, because if we go to our queue init, we have init queue and we have queue ready. And it's 44. I am written one to that queue ready. But regarding queue num, should I write the count or the total? I just wrote 1. me. I'm talking about that is fine. It's Q num register. Number of descriptor entries. Wait. Q num. What the fuck is it's queue size, number of elements in the queue. Right, also it's the new one, right? Yeah, it's the new one. My queue size is 12, but I am only using index 1, index 0 with 3 descriptors in it. Wait. Maybe we have to pass the queue. Do we have queue? We don't write the queue directly. Okay. So if that is irrelevant, even adding 1 here should not, even if I put 12 here, should not make any difference. Because as long as I have just 1, it should not make any difference. And finally I set queue ready. I think it's just fucking good. But changing that 12 should not make any difference. We have queue selects, we have which queue ready, we have which version, we have ID, we have features, we have the max queue size. Wait, max queue size was max queue size. Max queue size is 1024. So that's also just fine. And we register those. Unit queue, I think we select the first index and made the queue ready version. Queue max size is 1024 and my queue size is 12. That's also fine. Okay, so that looks fine. Now what happens after we init the queue? After we init the queue, I guess we go back to our k-main, and here we init queue and then we allocate the data and we update the data. Hopefully my I++ is correct. Oh, let's just put and then we allocate the request, and inside the request we set a request type, which is out, and sector is 5. What is the reserved individual BLK request struct on to write to sector 5. So it's fine, it should be set to 0. And we take 3 values in our descriptor queue. And we set the values, which is request and size. Maybe I should just put size as type is probably type reserved and sector. I don't need these two. Because that okay, I'll just remove these two and I only have three things now. This should get correct length here, and the flag is next, and the next index is 1, and then we have the data, and data we need to give 512 because we are writing sectors. And finally we have the status. Status is just uint8 value, so we pass that address here, and the length, I think length is just 1 because there's just one uint value. Okay, and then we have the avail ring. What is this avail ring? Just this. So we use avail rings index 0 and set that with the index that we have used, and set the index to 1, and we notify you notify should have what value. Okay. And regarding the avail ring, which Q avail? Q. Um, After the device writes a descriptor index into the used ring, if the flag is 1, the device should not send. So this should be here, it just should be ignored. If it is not negotiated, so it's a feature. If it's not negotiated, device just must ignore the value. It should be the queue size. In my case, queue is 12, so there should be 12 rings. Okay. Okay, I still don't. I just still feel like we have implemented everything there exactly as the specification says. I still don't know why they have added a legacy implementation into this specification. It's just fucking confusing. Sometimes I'm reading the legacy docs as if it's the actual version 1.1. Okay, I think we have to let's keep this. I think we have to update this flag with 1. Even if the bid is not negotiated, we actually have to may, it's not must. Okay, but it should definitely set it to 0 or 1. Okay, let's just set it to 1. Let's queue. What? The driver must perform suitable memory barrier before index updates. What is this? Maybe this is the missing part. I don't think I have anything related to memory barriers. What's that? Was memory barrier? What is a memory barrier? Okay. Okay, so what we implement? Maybe is it like ISB operation? I have clang I think it's like this ISB. Yeah, I think it's like this because even during our MMU we wrote something like this. Is it fine? We just call ISB instruction. So we just call DSP then. DSB and DMB. XM ASM those. Yeah, we do have DSP here. Okay, we can just put into helper. We just have to call ISP for some reason because things might be in catch. So which places do we need to update this? Maybe we need to call it everywhere. Well, let's just call it let's call it here. It should be ASM volatile. It would be nice if we just have one helper. Static inline void which IO EMB is going to be void true. It is going to be volatile. Do we not need DMB? Yes, why? I think we don't have any output, so this is empty, and then we have memory. Which IO MB. Let's just call it after every sort of operation. Okay, we wrote here, so let's call which IOMB here, and let's call it here, and let's call it here, and let's call it here. I don't know where should I call it. I'll just call it everywhere. Let's call it after this too. Okay, it's still running. We have to also fix one more thing, which is I removed the negotiated part. Let's just bring it back. I don't know if it will. I think it will be good because we just want to read and write. So and we have errors. Why do we have errors? Some volatile. What's fucking wrong with this? Oh, it's just one. It's just my fucking faults. Now we don't see that next some log. And we don't see that here too. Let's see. Let's try this. Wow, status bit is updated. But it's not updated here, but it's updated here. Well, at least something is happening after we added the memory barrier. Maybe we have to add that in lots of other locations. It's possible. Okay. Let's then try to add it into our here. Let's add it here. And maybe here we might need it. Everything looks like it needs it. Well, then let's just put it after this. After we write, whatever we write, we also call which IO MD. Or how about that? What? What do you mean redefinition? Oh, save it. Now it fucked up. Wait, let's run it again. Maybe it's. Okay. Looks like it's the memory barrier. The memory barrier, maybe we need to add it in lots of other places too. I don't know. Okay, all those operations are already updated with DM. Okay, now maybe within K-main I might have to update it somewhere. Where do I use those actually? This is initted, and then I have the request, and I'm calling it after that, and then I have the kernel, and I'm calling it after that, and then I have the value, I'm saying I don't want to be notified, and I'm updating it. And we simply try to read it, and it is getting updated. Let's try one more thing. Maybe, just maybe, we don't need this. What if we don't negotiate anything? It's sometimes works, sometimes it does not work. Not work. Let's try one more time. Okay, this time it worked. So let's try Kernel. Okay, we have extra things here. Handle right to sector 5 and status is 1. Oh, that's new. Okay, now let's see. Okay, so now our implementation is fine. Internally, it is not able to write to it. Okay, that's at least something. So what changed is that uh, we did two changes. One is that we um, removed this. We added this flag. Because we added this flag, we don't have to handle interrupts, I guess, because we are not expecting any notification. I don't know, at least that's how I'm going to interpret it, because this, we only changed two things, everything else seems to just be fine, or at least based on the specification everything else seems to be fine. But we have added memory barriers, that seems to have helped a little bit. And we also added this, and we are able to see 3 new log messages, because previously we only saw till this, which is that we wrote to here and we notified it, and then now we have a write request to sector 5, and we have a okay, let's see what is that error. A device must set the status bit to for a write requests if the BLK feature but I didn't even have that. I only have one feature enabled. Okay, let's enable this feature. And this status is still 1. Well, let's see. Let's change the sector to 1, the first sector. Okay, let's see it come on. And it's still 1. Why is it not able to read? Is there no sectors? Okay, wait, let's check. Can we check the number of sectors for device? Camera monitor. Okay, I just put info block. Let me connect to it and see info block. It just says that. It does not say anything. But you must check the size of the file and the host system. So there is enough sectors, and I still get error saying error with status 1. And I did update it. It is updated. What? LSLH, next. It is read and write for me. Okay, if you want it, I'll just put image mod 777 next 4. Strings x4 444. We write to sector 100 and we test it here. Sector 100. And we test it. And we read 2. There's just zeros, nothing there. Yes, x4. It hasn't been written since February 20. Fab 20. Okay, let's see if we can read from sector 1, and we have to put write to I think there's nothing much there. Okay, if we read Kernel. Now we made a read requests. Okay, let's see if it is in the buffer. After we do it, we also print your printer. There's nothing in the fucking buffer. but we can't exactly. Well, we can do one thing. Write bytes and seek to the hundredths. What? And if that right. Test. Okay, now we rope to that. We rope to that sector. And we read. Can we have both read and write? Is that even possible? No, we only have appends. Okay, that's fine. Okay. Now if we put string text image, we just have this. And if we run it, okay, so if we do that, we are messing up with the entire structure. Oh fuck. Now how do I bring back my X4 image? Do we have it anywhere? Oh. Okay, fuck it. I don't know how I created it. I think I used some. I did not write it down, so it's forever lost, I guess. No, wait. It must be here. It must be here. Run. Oh, I created it with the Docker container. I just remembered it because it's not possible to create this fucking thing in Mac. I just messed up. Wait. Baud root fs. Jam fs. It must be somewhere. string. File root fs. Okay, this is also x, so let's just use this then. Image into kernel x4. Hopefully the 100th sector has something. It should have something for sure, but it does not have it. But let's confirm it by data is a pointer. So we'll probably have to use this. And let's do 3, 4. Let's try. See what we get. We got zeros. We didn't get anything. Well, but we wrote something and it's zeroed. Maybe it's working. Let's try. VI tests CD kernels. VI tests read read the 100th sector. Let's see what's in it. 100th sector is just zeros, that's why. Okay, let's try 1000th sector. That's also fucking zeros. And how do I wait, should be, do I have hex editor? Hex dump, okay. Oh shit. Less. Okay. I mean, there's just so much data. How come the 100th sector does not have anything? That's so fucking hard. Let's just read. We are reading sector 1. And what if we read sector 0? Let's put 512. And 512 plus plus, and put this here. And remove this. Put I here. Let's see if we have anything better. Just 0, 0, 0, 0. Okay, let's try character. I don't like this buffer. Now let's try. It's nothing. What if we put D? It's full of zeros. That's not even possible. We have a read sector. Let's put sector 1. And it is writable. It's nothing. Just zeros. And status is successful. We read sector 1. And sector 1 says ret is does it does it say how many bytes were read? Maybe it's my memory location. Does this need to have some permissions? So everything else seems to be fine. We have read only and we have write only. Okay, guys, fuck it. We'll see next week. Let's just write down something for us to remember what to do next week. We have added memory barriers and we updated the flag to 1 in the avail ring. Now we see the logs with camel logs with status, but nothing much changed. Maybe we need to try to think about modes, because the specification says that we should only have read only or write only permissions, and I don't add that. Okay, guys, thank you. Have a good day then. Bye bye.